Hey
Hey,
everybody, welcome back to the stream. I'm Brian Tang. I'm a senior solutions architect at AWS. And Chris?
yep. And I'm Chris. I'm a solutions architect at AWS as well. Thanks for joining us again.
Yeah, and if you haven't been to this stream before, Chris and I work with consumer electronics customers and manufacturers. Coincidentally, they sometimes are the same. And we wanted to share our stories and also spend some time chatting and doing some system design, which is always fun with the audience in this space. Hey, do you want to do a recap of like what we talked about so far? We had like this is what episode 5, episode 6.
Yeah, we've done a lot, honestly. Actually time flies how many episodes we've done already. But definitely just recap last time or the whole series.
Just do the whole series.
The whole series? Oh, I don't think I can take that far that far behind. If you want to take lead on that.
I mean, we kick things off with actually, well, we have a record of stuff we've
Oh
drawn
yeah,
for
fair.
people
We can do
to
that.
uh for people
But
to
yeah,
look at.
let me see.
Um,
I'll pull it up.
maybe this will jog your memory. Yeah.
Oh yes, yes. So I mean, essentially, we the premise of the first couple episodes is really like building out smart home type of IoT type appliances in terms of like whatever it may be to be able to optimize your home for like IoT specific type of use cases, right? So if you wanted to potentially be able to turn on and off light switches, like as an example, or we talked a lot about like recognition in terms of your door, like for just optimizing overall flow of your house, right? Because I think if we might have some viewers as well trying to dabble into specific smart home type use cases in their daily life. So it's more so enabling us to showcase to you from a technical perspective how this actually works underneath the hood, and while using some of our AWS core services like IoT Greengrass, like IoT Core, and the cases Firestream to be able to make this happen, right? So um, and then we did discuss a bit more around like authentication. And the last episode, we actually got more into like AI aspect around certain assistance of how AI can really be able to play a role within anomaly detection of certain aspects of a smart home possibility. So a lot of cool things that we keep just wanted to build on top of for future episodes. Uh, and I think today we're going to get more into more of like the video aspect as well, right, Brian?
Yeah. So if you actually go back to our first stream, we had talked about things that were in future episodes, and the future has arrived. So at the beginning, we were basically just talking about everyday home items, how they could be connected, and then we could try to space it out into what people are using at home, and then from the perspective of if you're a company that is making these products, how might you be supporting all the features that uh, you've that the users want, and like I think in the scope of this show, we try to keep things at a fairly high level. That this gives you a roadmap of if you're designing and building a system like this, what are the main like headline features that you need? And we always start off with like a general box, and then we introduce the AWS services because the AWS services kind of take a lot of the heavy lifting away, right? So like if you were just to look at something like stream ingestion, like if you were to build your own stream ingestion thing, right? You need to set up all the infrastructure. You need to build all of the individual components to like do its own buffering or like be able to have clusters of services, be able to manage moving data from one place to another at high speed. And this is like what AWS services kind of solves for you. But that said, we do want to talk about video streaming today. And then as a second topic, we'd also like to cover something that's very close to the AWS. What would you say it like? The well architected
Yeah, well,
principles.
architecture principles. Yeah, exactly.
The And sometimes we do things called well-architected reviews. It has a very aggressive acronym, WAR. And this is one of those pillars, right? Because once you've achieved a huge scale in terms of you've got millions of users, hundreds of thousands of transactions per second, the cost of downtime is very high. So for instance, like stepping outside of like smart home for a sec, if you're talking about like a retail company on Prime Day, where you're expecting like $13 billion in sales over the course of a Prime sale, if you're down for like an hour, that's millions of dollars that are at stake, and that's where things like resilience plays a piece. And then if we're talking about like the smart home products or the space that we've been talking about in, that downtime could be, if you're not designing right, people not being notified when people are at their doors, trying to expect deliveries, or maybe your light switches are not responding to your commands.
Yeah.
And that's why you want to think about resilience, maybe at the edge also, but in the cloud as well. And I think today we'd like to focus more on resilience in the cloud. Great. Is anybody in the chat? Does anybody have any questions? All right. I'm going to insert a new slide. Whoops. Okay. All right. Let me insert a new blank slide. There we go. And we're going to draw on this in a bit. But before we jump in, I do want to talk about our topic, which was, hi. That's Chris.
Yeah, I'm the only one in the chat right now.
All right, I'm going to put this here so we look busy. Feel free to put any questions in the chat. Let's talk about video for a second. I think if we're thinking about video, that is actually quite a complicated topic, right? So imagine you have like a doorbell with a camera. There's a lot of functionality that you want, and there's certain things you want to be able to do. Let me make this a bit smaller. Wait, don't judge me. I'm clicking.
No worries. We can see it.
Yeah, so you've got like there's like two ways you might want to work with your camera, right? One way that I can think of is just like a streaming use case. I want to be able to just hook into the doorbell and look at what's going on outside my door right now. But that's not like a very common occurrence. Like, how paranoid are you that you want at all times to like look out your front door via your doorbell? Most likely you're probably also just like, you can just look outside.
Yeah.
You're doing that at that point.
Or maybe if you're in Florida and you're in like an alligator or a crocodile zone,
Yep.
I want to do that, but
but that's the thing, like maybe you only want to get notified if you see an alligator, right? Or you only want to get notified, or maybe you just want to get notified when there's any movement, right?
yeah,
So
sure.
that's the other one. So like maybe you have video on demand with clips and notifications, with playback and notifications. And I think that's like these two types of use cases are good ones to think about, because there's always like trade-offs when you go one or the other. Obviously, like everybody wants everything now all the time, but there's a cost associated to that, right?
Yes.
So
Always.
yeah. So that's why you design things with some trade-offs. Like, okay, video on demand with playback and notifications, yes, it'll be slightly slower, but like realistically, with my lifestyle of being super lazy and only want to get up from the couch when I need to, that's the type of thing that is cost effective for for a company to design for as well. Okay. So I need something to represent the doorbell. I'm gonna look for some icons. Let's see what we got. So let's say let's focus on the video processing piece for now. I'll just put this title up here. Video processing clip or VOD pipeline. And I just want a little icon to represent my camera. It's a doorbell, but let's just say it's a camera for now. And you want to go, you're probably going to traverse the internet and you're going to be collecting like a video. And usually it'll go somewhere. And what kind of storage makes sense? Like, I think this is a very basic question. Like block storage or object storage or file storage? Like, what do you go with? What would you pick, Chris? And why?
Well, let's see if the viewers want to take a stab first.
All 44 of you.
Let's try to get some participation. But I mean, for me, if I were to answer, I would ideally go with like Amazon S3 for like clips and snapshots, right? Since that's our most durable, cheap storage, high resiliency, right? So I would lean towards S3.
I think that is a good choice. I think that makes a lot of sense. And something about this that you should know is that you normally don't just save video as is and then you can play it back. Usually it saves in one type of format, but in order to have like playback, you have to process it in some way. And that's called like transcoding. And then that's where you'll see like people mention something called codec, which is basically two words crammed together, encoding and decoding. And that's just, at least for the purposes of this exercise, we'll just say that you have to process the videos before you can play them back. And that's pretty much what we have to know for now. Okay. All right. The other thing is, so we're talking about like processing the video so that we can play it back later. Now, when you drop things in S3, you have the ability to, process them, but like, how do you know when like the encoding service should process it, right? I think CloudWatch events is the thing that comes to mind. So when we talk about like event-based architecture, it's just like when something happens, use that like output, that message or that event, and then and use that to process. And one way to ensure that you're like handling for like scale, so you're thinking of millions of users, lots of events happening. You may want the idea of a buffer. Whoop, go ahead.
Sorry. Oh, sorry for cutting you off, Brad. But we just had one question. I don't want to botch your name, so I don't pronounce that. But what about streaming video, not case with record to bucket?
Yeah, so streaming is a slightly different use case. There's a lot of different ways to do it. I think if you're streaming, you're not necessarily it's a different flow, right? Because the idea of recording something, dropping it in a bucket, processing it, and then like going back to that processed file and looking at it, there's a delay. So streaming, there's a whole different way of doing that. And I think we want to cover that actually in right after this one, because it is pretty complicated.
Yeah, it's definitely handled in a different way from just regular object storage as well. So yeah, so we'll talk about that in terms of how Kinesis video streams plays a role into that. But good question.
Yeah, and hopefully it doesn't scare you. So what we'll do is we'll like kind of sketch out what streaming setup usually looks like, and what are all the actors that are involved, and what are the protocols that are involved, and then we'll just show you how like Kinesis video streams just like takes that away from you. So,
Yeah.
yeah, I think that would be helpful. Right. Okay. We said something about, okay, we've got events. And usually when you have a lot of things that you expect to process, you might want to put it in some sort of buffering area. And the reason for that is like things happen, right? You want to make sure that the events are placed somewhere durable. So if you have like something like a Amazon simple queue service, that serves as a pretty good buffer in the sense that you can place things in this queue and then you can process them. And then you have additional features like for whatever reason, because I think who said that? Werner Vogel that said everything fails all the time and you have to plan for that. Yeah, things happen. Like a connection could be off, or like there could be a spike in traffic, or maybe you get some bad data for whatever reason. There was like some unexpected bug in your application code that was like publishing a piece of code and is getting processed weird. So things like having a buffer gives you capabilities like having a dead letter queue. Like this message failed for whatever reason, and you can retry it later, or you can go back and look at it and see what's wrong. Why didn't it get processed?
Yeah.
Yeah.
Yep.
Okay. Video event. And not only that, but how do queues work, Chris? What do you do once something's placed on the queue?
Like just in general, like because for this we're trying to trigger some sort of action, right, for an IoT home, right?
Yeah.
So I guess like in this scenario, maybe if we have some sort of event that says that there's motion detected at 205, we want to be able to trigger some sort of event. So that's why SNS is kind of pushing potentially like a notification back to a user to be able to respond back saying, hey, we've seen motion to we detected motion at 2:05 p.m. something like that.
Yeah. Do I have something for SNS? I should find.
Right. So essentially kickstarting that overall approach for like any type of workflow that you want to do based off of a certain trigger event action. Yeah.
Yeah. Oops. Okay, so I think there's two things we can do. One is like SNS to send a notification to like to
Sure.
trigger like the workflow to get your push notification.
Yeah, that would be like going back to the user, like maybe an application going back to the user to trigger that notification on your phone. Right?
Yeah. So let's assume like there's something here that can trigger a notification. But the other thing that you could have would be like I mentioned, you have the input videos, but you need some sort of final playbackable video, right? So like I think one of the raw formats would be like H.265 format. It's a media file. I can't play it back on my phone, but I need some sort of transformed thing. And usually those can be pretty heavy. We have like managed services for that, but I think you can also have, if you have like a custom process, you can run it on a fleet of EC2 instances and just say like, let's just say Amazon EC2, like transcoder service. And what you're doing is you're getting the message and you're saying, oh, okay, I have videos that are landing in S3. They're in this raw like H.265 video. And you're processing it and you want something that eventually when I'm a user in the app, I can look at it and play it back. There's other things you might want to have, right? So
Yeah.
not only do you want the raw object, let's call this output videos.
Yeah.
You
So
might want to have
here,
data.
I was going to say, yeah. So here, SQS is acting as that orchestration between getting to another transcoding perspective of what Brian's talking about. But go ahead, Brian.
I was also thinking like usually when you have object storage or objects stored, you want metadata. I think S3 can have metadata, but if you want to do some interesting stuff, let's say, of like reading off of the history of a particular object, like this was the timestamp, or maybe you categorize the type of object it is, or something else. I can't think of anything off the top of my head. Like DynamoDB is like a very often I see it paired when you're creating applications where you're like, oh, I also want to have a store of like metadata about that object, that video.
Yeah.
Is it Amazon DynamoDB? Yeah. Whoops. Getting too excited.
It is Amazon DynamoDB, so confirming.
Okay. Something else. What else should we say about this? Oh, NoSQL. Anybody know the difference between SQL and NoSQL? And why might it matter here? Hey, Hacker God. We see you.
You're here with around 45 people, so welcome.
Yeah. Feel free to ask questions as well. Besides, am I the only one here? You are not. I mean, at least Chris and I are here. All right.
Yeah. Okay, we got a response actually. I'm not sure if this is the response to your question, but
oh, I recently built a self-managed video transcoder. That's cool with Docker. Nice. MinIO. I don't think I've run into MinIO personally. Signature, okay. And Rust for transcoding. Wow. Rust. Hardcore. Okay.
nice.
I've not looked into Rust myself. I probably should, but I typically just use Python for everything. Sorry. Now I want to upload to AWS and migrate those options to AWS services. I just don't know if I'll use containers or directly. All right. So when should you use containers, or when should you host it on like EC2 or something, or direct or on doc or running it locally? I mean, if it's like a home project and your project is running fine and it's able to handle the load, if you're thinking about moving to AWS, that's like if you're thinking about, okay, in the future, I might want to handle it for like multiple people. Now I want my friends to use my video transcoding service. If you've got containers, there's a bunch of ways you can host them on AWS. I think Amazon ECS is the most straightforward one. If you want even more stuff that is taken away that you don't have to deal with, then I would look at AWS Fargate. At that point, I'm just managing like some task definitions and some other configuration files. And I don't really have to spend as much effort fine-tuning things. And the other option is like EKS, but that's only if you're a Kubernetes person. But I normally don't go there as like my first option.
I hope that goes well. Looking forward to hearing more about that, Kanjo.
Yeah, that sounds really cool.
I think we left off on sort of SQL versus NoSQL databases.
All right, no takers on that question.
No takers.
Okay, so you go with like I think if you're trying something like small, typically I start with like DynamoDB. I don't or like if I don't know what my data model looks like, maybe I'll experiment with DynamoDB. But then there's a trade-off there, which is like if you're not defining your data model well and your application is writing all types of records, you might have really messy data in the end. Like, I think it's always worth at least exploring what your data model might look like, and then decide whether or not how you're going to be using the data, right? So like for DynamoDB here, I'm only having simple metadata about videos. There's not a lot of like relational data. I probably won't link it to like entities like home and
Yeah.
person and schools or whatever. Maybe in the future when it gets to like a data warehouse or something like that. But
Mhm.
for this, I'm just going to be like, okay, if I'm a user and I'm looking back at my videos, I might want to go to like a timestamp of like 3 months ago. I think I remember somebody was at my door and I want to like look at what happened. Is like not much relational stuff going on there. And it'd be really easy to like just look at my entry in DynamoDB and pull up that video associated video. And like something else that might be in the DynamoDB table would be the URL to the video, right? So not the video itself. And then I could just like open it up and play it back. So like it's just very simple and not a lot of interrelated stuff, which is why it kind of makes sense here. And it's also
Yeah.
highly scalable, global, all of that, resilient.
Yeah, it's just a very easy way to be able to, as Brian mentioned, maybe like you want to look back in terms of how many times motion was detected during some, maybe there was like a break-in and you want to go back to that certain time frame. It's very easy to be able to go back and say how many times was motion detected during this month, right? With this type of architecture. So
Yeah. And then on the other end of it, I have my phone and I access it, and that's kind of easy peasy. Oh, one other thing, you might want to trigger auto scaling, right? One of the ways you might want to do that, again, you might have metrics you're looking on the queue to determine whether or not to scale up or scale down. It's like, oh, how deep
Yep.
is my queue? How long are things taking to process? So usually you'd have CloudWatch. I'm just gonna have it up here. CloudWatch. Honestly, I think monitoring is one of the more slept on parts of design. I don't know
Yeah,
about you, Chris.
for sure. Should be table stakes though, but yeah.
Yeah. But it like drives a lot of what you'll end up doing. Like, when do I scale out? Or like, when do I have problems? That's like 60% of the things you have to deal with. So like making sure you think about what metrics should I be looking for and how is my application going to run and how can I respond to it? A lot of that's going to come from CloudWatch events. Cool. Okay, so that's like the gist of video, the clip VOD pipeline playback piece. Now I think someone asked about streaming. I think this
Yeah.
is this is the scarier one.
This is the scary part.
And I hope I can explain it in a way that makes sense. Okay.
Welcome back,
Um,
Pratik. I remember you from last time. Thanks for joining.
oh, hey, Pratik. Yeah, no worries. I mean, it's a stream. You can
Yeah.
drop in and out whenever you want.
Happy
Um,
that we had some repeat listeners though. It's always fun to see. So,
yeah. So what I want to do is I mean, we've got like half an hour. So within like 10 minutes, speed run streaming. and
this should be
then
fun.
and then try to get to resilience. Um, unless we want to talk about resilience first before going into streaming. Because I want to make sure like uh maybe we close the loop on this on this architecture. Um,
Okay.
but I promise we will get to streaming. Don't worry. And I'm not afraid of it. Maybe a little bit, but we'll get there. Maybe the first thing we want to talk about is like, okay, we said this is a very critical service. There's millions of users. Halloween is around the corner, and there's going to be lots of notifications that we want to see. So, what are the decisions we have to make? Like, of course, everybody wants stuff up 100% of the time, all the time. But I'm pretty sure 0% of people are willing to pay for that type of setup. I've never run into anyone that was just like, okay, like I'll pay whatever it costs. How do you determine how to design based on your willingness to pay? There's a few slides here that we can run through, and we want to disambiguate a couple of different terms, right? So
Yeah.
you can see the slide says disaster recovery. I said
Yeah.
resilience. There's also the idea of high availability. I mean, okay, Chris, how do you differentiate between those terms?
So I would say, I guess, kind of says it here in terms of like you want to think about big picture first, right? So there's every customer that we work with has an RPO and RTO objective defined by a role stack, right? So on the left, you see how much data can you actually afford to lose, right? And then on the right, you see how quickly can we actually be able to recover that data. And in the middle, you see that's disasters always happen, right? So that's representing that moment of disruption, whether it be a center outage, whether it be like a human error or cyber attack. So these things always happen within small scale, large scale sort of deployments, right? So that's really where we as an SAs kind of help the customer frame and judge based off of their sharing workloads what would be a proper RTO/RPO requirement, right? So think of RPO as the point in time where you can be able to rewind back without harming the business too much. It's like answering how much data loss is actually acceptable, and then RTO is like that stopwatch for that starts when disaster strikes. So it's answering like how fast do we need to be back online before your business really suffers. So based off those terms, you can kind of see like depending on the actual use case, like if it's a financial services application that has to be up 100% of the time, um, you see how varying levels of RPO and RTO can shape the overall infrastructure architecture. Because I believe there's another slide that kind of
Yeah.
goes through more of the strategies, right? Because at AWS we have a lot of strategies for your for like high availability or disaster recovery to be able to offset some of that RTO, RPO requirements, but also making sure that if cost is a concern as well, there's different options based off of those criteria. So
Yeah, I think the way I great explanation on RPO and RTO. I liked it. I think the thing that gets mixed up very easily is disaster recovery and high availability and resilience. And I think I
sure.
have my own view on this. Maybe people may look at it differently, but like this slide says disaster recovery, but like this pattern also falls into like resilience as well. Disaster recovery would be like, oh, something super unexpected happened, like an asteroid hit a region, and so the whole region is down. Like, how do you respond to that?
Yeah,
I think that's one way to think about it. It's like what, yeah, and you can take a screenshot.
it's a great slide. So feel free to take a screenshot. Yeah.
Um, the other one is high availability, and sometimes you can think of that as like even within a region, you can have high availability, and you have to define it some way. And that could be like multiple availability zones that within a region. So like if one availability zone is affected, the workload can flip to the other one, and the other availability zone can scale up and handle any disruption that could happen. And then resilience is just generally like how well can your application recover in general. So
Yep.
that's when you start taking into account like, okay, I need to have monitoring in place. So if there's any degradation in the application or any part of my infrastructure, I need some design that helps me like keep running. It could be degraded, it could be running slower, like we had mentioned, or yeah, and you have a way to recover over time.
Yeah.
So they're like very similar concepts, but I think it's important to like try to keep the subtle differences between them as
Sure.
well.
Yeah.
Um,
Actually, the way I actually was first actually learned it was described as like, say you're driving a car and then you have one tire that blows out, right? you might still have a spare tire in your car, spare tire in your car, so you can keep driving, right? So that's like high availability in terms of having like that extra tire in the back of your car. Whereas like DR could be like your whole car got wrecked, but you do have insurance in another car at home, right? So even though it's not instantaneous, you still have a fallout backup plan as like I'm not sure if that was the best way to describe it to you, but
Yeah,
I think that's how
I kind of like
I
that. Yeah.
first learned it. But yeah, feel free to grab the screenshot. These are very important slides as you go through any architecture on AWS and the cloud to determine, pick and choose what makes sense for your mitigation strategies for both DR and high availability.
Yeah. And like if we're talking about this workload that we just drew up, disaster recovery would be like, okay, I make sure that within this region, I'm in one region, maybe I have like cross-region replication to another region. And that way I can, if like for whatever reason the first region is disrupted, then I can continue processing from that second region and get it back to the user. So like me as their doorbell user, um, I don't see any difference. I don't care that it was in another region. I just care that I can go back and look at the video that I expected to record.
Yeah,
Maybe it was like a celebration or something that I wanted to get. Um, cool.
yeah,
But the big question is like, when do I decide? How do I decide when to scale out? If I'm Ring, yeah, I'm gonna go like multi-region. If I'm at home and I just started spinning up my own service and I'm like, maybe it'll become a startup one day. That's like a trickier discussion, which comes to these slides. And
yeah.
I think this is the one that is harder to explain. But
We can tag team this one together. But
yeah, we'll get through it.
um,
Oh wait, we have a question in the chat though from Pratik.
sure.
Ah, yes. For like a global business with millions of users and a high cost to the impact of it, there will be multi-region implementation, right? Because um, the business made some determination that like they're willing to pay X amount as like an insurance uh, in case of a disruption, and it's worth it to them. And like I think one of the things we wanted to run through here is how do you like even start understanding how to make that decision. I think if you think about this slide, it's actually missing something, which is like uh there's like a temperature gauge of like how long it takes to recover, and then the longer it takes to recover, usually the cheaper it is because you're willing to incur like more data loss or more downtime. So you don't need stuff to be like on really fast. So the idea is like cold, which is like you just take backups like we just talked about, and then eventually you spin up new resources and then you process them. Or like the other one is pilot light, so a little bit
Yeah.
hotter. You have like a small scale deployment in another region or something like that, and then it spins up when you need it. And then the full like hot active yeah, you have the duplicate workload running in a separate region because you just can't afford any amount of data loss or downtime. And
Yeah, and
that's
as you think through those, this chart kind of expresses how both the cost of the business impact and also the recovery costs, and also just as if it's an active architecture, just yeah, you have to understand that there is also more associated costs as well to the actual business. So these are things that this chart is trying to explain in terms of if your RTO RPO requirements are the lowest, it's going to be higher up in cost, but then you're able to mitigate any type of downtime because you already have that resiliency set in place. And then as you go lower in terms of like in terms of whether it be a pilot light strategy or a warm standby strategy where you have an additional region that is only spun up when the main region goes down, you do have a trade-off of potentially higher RTO RPO requirements, but the cost might be less compared to an active site, right? So this is a very important chart just to be able to see the trade-off between a very low RTO where you have near zero downtime, you might have to pay more for architecture. If you're okay with more of a higher RTO, you can save costs, but you're still risking more of that business impact of data loss. And then the sweet spot is really where the recovery cost and business impact intersect. So you see it a little bit here. You see it in the chart in terms of like an acceptable recovery cost for your business, right? So yeah, Brad, if you want to add more to that as well. But
Yeah, so like what determines like what decision you make, you need to figure out what this line is. Like how much am I willing
yeah,
to pay to recover?
yeah, exactly.
Actually, and for each of these, there's actually reference architecture for like backup and restore, for pilot light, for warm standby, and multi-site active. And I'm gonna drop that in the chat. Where is it? Here we go. This blog series is awesome. Okay.
Yeah.
Yeah. And it's like similar thing for recovery point objective is like how much data are you willing to incur? Data loss before service interruption and the cost. So this line is a little bit weirder because it's mostly about like data, not really like compute. So typically for data, it's not like as much stuff to spin up. And this here, backup and restore, is actually lower cost, but you have to be willing to incur more data loss over time. Say you're backing up something like every 3 days or every week or every quarter. If you're willing to lose up to like the whole quarter's worth of data, maybe you are. It could be a fine option. Cool. Awesome. Now, going back.
All right,
What does this mean?
now we'll tackle the fun part.
Wait, I'm not ready yet.
Oh, not yet. Okay, never mind. Take that back.
I think like what does that mean for this, right? We just talked about all these business decisions about like how much should I spend to architect to make this more resilient or pay more for disaster recovery. And I think that is what we should try to at least envision, right? All right. So let's say this part of the workload that's running on AWS is running on AWS for sure.
Hope so.
I'm not aware of any way to run AWS stuff elsewhere. So we want to do a resilience focused design. So like right now we've got pretty much just these services up and running, one region. We didn't really talk too much about how we're processing data. But let's say we have like an API layer. Okay. Sorry. There. I like putting stuff outside the box. And then we have something that's like a processing layer because we need to process the data or process the events and the data or the videos. And then something that I've seen on another doorbell company is they actually make they made a consumer proxy layer. And then at the very tail end, they have all the consumers. And the reason they did this, from what I understand, is it gives them a lot of flexibility when they were thinking about something called a cellular architecture. So you know how we talked about like resilience, making sure you design your architecture so it can recover. The cellular architecture like isolates parts of your architecture. So like if any one place fails, you have some redundancy.
Mhm.
And not just redundancy, but like alternatives to handle like degraded behavior. Like I can no longer stream from my doorbell live, but I can still it still like turns on and records and I can look at the VODs. It might take a little bit longer, but it's still possible. And the cellular architecture also leans on something that I've seen quite a bit, which is each little service has its own account. I don't know. Have you seen that yourself?
Each little service has its own account. I think I have. I'll say yes.
You don't have to say yes. Like everybody sees different things sometimes. Well, the idea is like, let's say you have a production account and you're a huge enterprise and you have consumer electronics stuff, and you have your IT services and your finance services and your HR services, and you decide you're going to put them all in one account in one region.
Okay, yeah.
That is something we would refer to as it has a large blast radius, which means if something blows up in one account, you basically just impacted everything. So like the idea of separating the accounts and like
Yep.
putting things in different regions is like you're protecting each individual thing, and that's also the idea behind like the cellular architecture.
Yeah, for sure. Yeah, definitely just limit the blast radius. Yeah, and then it's very similar to like how you would like microservice, like how you would break up an application in terms of just making sure that yeah, individual components are not blocked in terms of it all being within the same account. So
Yeah. So let's say I'm just gonna keep it like kind of high level. So say you have like you have the API layer with some sort of compute running. I'm going to look for like a container service for now to represent like some lightweight service. And then you have some sort of service account, and there's just some sort of like communication that's happening between these. Oh man, this okay. And when we're processing the data, right? You have a data plane account. Maybe you are having like a Kafka like streaming topic based layer to get the data out as quick as possible. And then you have two of them, so you have like a clone of them. You have some sort of let's say I'm gonna grab a Lambda icon. Lambda. Maybe it's
applaud you
giving.
for
Yeah,
all this multitasking, man. It's impressive. Every
no
stream.
worries. I may not put the labels on it for now. Just know that this is Lambda. Maybe it has like some configuration, minor automation, and then you have Kafka streaming. I think we talked about Kafka in previous
Yeah.
discussions. But if you have like you're trying to minimize latency as much as possible and get the data from point A to point B as fast as possible, you pick a streaming service. And there's like the AWS fully managed Kinesis data streams. And then there is actually, what is it called now? I think there's another name for it. It's Flink now, right?
Yes. I'll put a link for the service in the chat as well. It's Amazon managed service for Apache Flink.
Yeah. And then the other one is like most of my customers have been using Kafka, so I kind of threw that in there. And you can either manage the Kafka clusters yourself on EC2, right? And have like your zookeeper and all your like your brokers, and there's a bunch of other components associated with it that you have to juggle to make sure that they all coordinate, that they have they themselves have some redundancy, and they're able to handle the data as it comes in quickly. The idea is the main idea here is like you have cell 1 and cell 2 with exactly the same types of services ready to go, and they're both processing data from the service account that's coming from the outside world. And then the idea is if one of these cells goes down for whatever reason, the other one can either you might have like some slowdown as this one scales up, but you could also handle it so that it could be like an active setup where if one of these cells goes down, the other one can scale up and handle all the load, and then the users never realize that there's anything wrong. So let's just say cell one went down. And so that's the idea behind cell one and cell two. Like you have the same architecture.
Yep. Yeah, everything ties back to what we just discussed in terms of resiliency, right? So yeah, it's important to know how each layer can be affected via those resiliency aspects that we just talked about earlier. So
Um, and the other thing is like, okay, so even let's say it's like within one region, right? You might have actually, or for whatever reason, one of these cells has problems. You can switch to the other cell, but sometimes there's something called a correlated failure, which is like whatever was causing Kafka and Lambda in some reason, in some way, to have issues processing the data or like an issue with the service. What else can you do, right? So this is where you might want to change your architecture to have like let's call it like a fallback cell. And this is what we mentioned when we were talking about like degraded performance. It sounds bad, but it's better to have it running a bit slower than to not have it run at all. And in the case of this VOD, like maybe I might feel the effects of the different architecture of like, okay, I should have got the notification in 1 to 3 seconds, but I got it in 5 to 10 seconds. So
yeah, it's
yeah.
it's a good term is graceful degradation. So it's yeah, at least you're still being able to be served and that content back to you, even if potentially transcoding has failed throughout the process. So it's more graceful versus not. So
Yeah, and we talked about like the events could have been streamed, not video. We're not talking about video streaming. I think that's probably for the next
oh,
episode.
sorry. Yep, got ahead of myself. My bad. Yeah.
But we were over ambitious about the content.
Yeah.
But here we were talking about like streaming the messages to the consumer proxy layer, but there's also the idea of pub sub, which is like publish subscribe model. Oh wait, here we go. Pratik mentioned circuit breaker retries also required.
Also required.
Yeah, that's actually a good point. So
Yeah.
circuit breaker pattern, for those that may not know, is like if you think of a light switch. Is that the analogy? Yes, a light switch. When you close a circuit, the electricity is flowing, so it's running. But if there's a problem, you want to break the circuit so you don't like blow up your light.
Yeah.
In which case, so you need some mechanism. So say in this first case, cell one and cell two were fine. But then there's something in there's a problem in cell one. You need something that can make sure like your traffic is no longer going to cell one and it's getting sent to cell two. I didn't really talk about networking here, but there's ways you can do that with networking. But then there's ways that you can use monitoring to determine whether or not and where to push your messages. It's like, oh, okay, you've tried like 3 times, or I noticed that there were like 5 to 10 errors with the message processing in the last 3 seconds. You know what? It's time to switch over to cell 2. And then you have to think about not only sending the messages to cell 2, but once cell 1 recovers, right, you need some way of indicating to the whole system that cell 1 is back up and running, and you can now distribute the messages properly. And that goes with any combination of these.
Yeah, that's why determining your RTO and RPO requirements from the get-go is very important, because then you can be able to see how you can be able to potentially tighten those targets along with circuit breakers as well, right? So good call out, Pratik. It definitely can be handled together in terms of making sure you're able to hit upon those certain RPO requirements, whether it's a short-term failure or like a persistent one. So
Yeah. And just to close the loop on this, say let's say there's a consumer account here and you're ingesting the data. Your services may be ingesting the data directly from the stream. But then with like a pub sub model, you may want to add like in any of the cases, you may want to add like a SQSQ as like a buffer. Whoops, maybe not the prettiest color. There we go. Oh, that's kind of gross too. I don't know. Any suggestions from the chat on the colors? This color scheme is kind of gross. There we go. My arrow drawing capabilities are not representative of everyone at AWS.
that's funny.
Disclaimer. Wow. It says it's straight, but it doesn't look straight. Anyways, but it does go back to our earlier talk about like, okay, sometimes we want to think about having buffers. So like, it's always good to think about it if it makes sense there. And then with each of these services, there's quotas, right? So SQS you can look at the quotas page. Actually, I'll just take you there now.
Yeah. Just another point. Yeah. These buffers are very important in that, if the transcoding portion of the processing were to fail, at least the jobs won't disappear. They're still sitting within like SQS until those working nodes would come back online. Right. So that's really reducing the data loss perspective as well from your RPO and also at the same time speeding up your RTO objective for that recovery. So
I'm gonna add dashes here and say like when you're making your decision, I think this is a common question that I get from customers like, but how do I know whether or not I should do this or not? I think look at the limits. Look at the quotas, I guess is the word. And then if you're an enterprise, typically you can request a quota increase or depending on what quota it is and what service it is, and like what the justification is for extending the quota. So like if you look at the quotas and you're like and you look at your traffic and you go, okay, like SNS isn't going to expect to reach this amount of messages, and I'm only going to have like a handful of subscribers, and my service is consuming it at like, I don't know, 10 messages per minute. Like I may not want this queue or.
Yeah. By the way, Brian, we're at 1 minute until it's 1:30.
Yeah.
So one more.
Okay, so we covered a lot today. Sorry we didn't get to the streaming video, but I think we can just talk about that all next week or next
exactly.
week. Sorry about that. Happy to do that. We did cover a lot about resilience and really appreciate all the questions that people are coming. Hope you got some good content, screenshots.
Yep.
And happy to have everybody on the stream.
Yeah. Thank you, everybody. We'll see you in 2 weeks.